Okay, in this video I'm going to talk about these different averaging methods. I'm going to try and explain this as clearly as I can, but I often find that I kind of fumble when trying to describe these. So hopefully this will be clear. Yeah, okay, let's get into it. So this one I use the absolute time. And actually to help me, I created this graphic for the SipperViz manual. That's where I'm taking this from. And this is basically the same averaging methods, just with different names. So the one we just used is this date and time, or what in SipperViz is called absolute time. So that means when we create an average, we're just going to look for places where all the files were active at the same time. And we just want to say, okay, for the dates from February 1st through the 8th, for each hour we want an average of the data. So yeah, that's what this graphic's trying to show here. So this is a good use if you have an experiment where you recorded files all at the same time and you want to be able to preserve kind of the circadian pattern of everything. So the thing to note here is if you have files that are recorded at a different time, so let's say that this is time on the x-axis, there was some file over here that I recorded. This is going to cause an error then, because it's going to note that there's no time when this file was recorded with these files. And in SipperViz, it'll actually have a little pop-up that comes and says you need to select a different averaging method. So that's what that means. I can actually do that really quick. So if I'm going to load just some more files, and let me these are the new ones I added. Yeah, and these are all active during different times. So I'm going to create a group with them and call this just B for now. And if I try and create a group with this absolute time setup, if I try and create an average plot with this averaging method of absolute time, I should get this error. There are no intervals where the selected files all overlap, and then it wants you to go and then change the averaging method. Okay, I'm just going to delete these files for now. So that's what that means. So what are the other options if you have files that you want to average but they weren't recorded at the same time? So I think the simplest one is elapsed time. And that's this one here, which is basically saying we just want to align all files to the same starting point. So just going to basically shift them so that their 0 points are all the same, and then take an average. And note that if there's overhanging data over other ones, it's going to create an average for whatever is there. It's going to just ignore missing values. So this can be useful if you want to see basically kind of the rate of drinking from the start. If you know that you have different files that you all started kind of the same experiment and you want to see how things are changing over time, from when you put the sipper in the cage, this would be a good one to use. But note that the circadian information gets lost. If you had two 12-hour files, but one started at 8 a.m. and one started at 8 p.m., then it can still make an average, but it's going to lose all this circadian data of when was day and when was night. So I can do that for these ones again. So I have elapsed time selected now, and I'm just going to create the plot again. And you'll see that it's very similar because these plots were recorded at the same time. Yeah, it's now the x-axis is elapsed hours, and this shading of the dark periods that you see here doesn't happen anymore because that doesn't really make sense anymore. Okay, so if you do have files that are recorded at different days and you also want to try and preserve kind of the circadian information, this last setting, which is relative time, that is the one you can use. And here it's called shared time. So that basically means we want to align files so that they start around the same time, but also kind of their time of days are all matching. So, if I had a file that was recorded in February, let's say file 1 was recorded in February, let's say I have another file that's out here recorded in March or something like that. It's going to move this file back so that it's aligned with these files and also the time of day is matching. You can kind of see a little example of this here where this one is recorded for a day and a night, but it starts after file 1 starts. So this averaging method is going to move this file back and say, okay, this was like 8 a.m. on the first day. This was like midnight on the first day. And then it's going to make an average. Okay, so again, we can do that for this one. It shouldn't look so different also. The main difference here now is that it's just longer because it's continuing to make an average for just the longest file here. So I guess I can load some of these files again and just show that this will work. So these were some where they're recorded at different dates. These ones are in October, that's in November. So let's create a group with them and call it example. I'm going to go to plots and groups, and I'm going to select this example group. That's all I want to make a plot for. And I'm going to make the averaging relative time. And let's just increase the bin size a little bit. So then if I do create plot, average drink count, you'll get this really weird graph. And that's partially because we don't know what's going on in these experiments, and partially because we don't know what was in the left and right bottle at each time. So that's an overview of the averaging methods. I think the basic takeaway is use absolute time if you have files recorded at the same time. Use elapsed time if you want to align files by the start date or start of the recording, and use shared time or relative time if you have files recorded at different times but you also want to preserve kind of the circadian pattern of things.